Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P0450 signifies an issue with the fuel tank pressure (FTP) sensor located within the fuel system of the Honda Civic 2022 and newer models. This sensor is crucial for assessing the fuel tank's internal pressure and ensuring that it operates within predetermined values. When the sensor output voltage exceeds acceptable limits, the Powertrain Control Module, PCM, registers this anomaly and logs the DTC. The FTP sensor plays an essential role in maintaining the vehicle's emissions system by detecting any vacuum or pressure changes in the fuel tank that could indicate issues such as leaks. The sensor is typically situated near the fuel tank, connected to the fuel system's wiring. This issue is characterized by various symptoms, primarily related to the vehicle's performance and emissions control, and requires thorough diagnostics to pinpoint the fault accurately. The fuel tank pressure sensor, FTPS, is a critical component that measures the fuel tank's internal pressure and lets the Powertrain Control Module, PCM, know if it is problematic. Its role is to detect changes in pressure that would indicate a fault in the fuel system or evaporation control. If the FTP sensor outputs a voltage reading that exceeds specific thresholds, it triggers the PCM to store the DTC P0450 to indicate a malfunction, typically found connected to the wiring harness near the fuel tank. This sensor is integral to the vehicle's overall operation, affecting both fuel efficiency and emissions. As fuel evaporates and pressure fluctuates inside the tank, maintaining the correct pressure is essential for optimal engine performance and environmental compliance. Understanding the FTP sensor's position and function aids technicians in diagnosing the problem accurately. Diagnosing DTC P0450 requires insights into various potential causes. A faulty fuel tank pressure sensor is often the most immediate consideration. If the sensor is defective, it may send incorrect voltage signals to the Powertrain Control Module, PCM, triggering the DTC. Wiring issues are another possibility. Damaged or corroded wires in the circuit can lead to faulty communication between the sensor and the PCM. The final cause could be the PCM itself. If other components in the system have been tested and found functional, the PCM may need to be inspected or replaced. Investigating each of these potential causes helps technicians isolate the exact source of the problem, which is key for effective repair. When the DTC P050 is triggered, several symptoms may manifest, affecting the vehicle's performance and safety. The most noticeable symptom is the illumination of the check engine light on the dashboard. This warning indicates that the vehicle's onboard diagnostic system has detected an error and requires attention. Additionally, drivers may experience poor fuel efficiency due to the engine's incorrect adjustment based on erroneous sensor data. Increased emissions are another concerning symptom. As the vehicle struggles to maintain optimal pressure in the fuel system, the emissions control system may also fail to operate effectively. Other potential symptoms can include rough idling or stalling, particularly when the engine is under load. Recognizing these symptoms is essential for both the technician and the vehicle owner for timely intervention. The first step in troubleshooting DTC P0450 involves confirming the fault by manipulating the fuel system's environment. Begin by inserting the emergency fuel funnel into the fuel filler neck as a precautionary measure. This funnel is typically stored in the vehicle's trunk toolkit for accessibility. Next, turn the vehicle's ignition to the on position, which powers up the vehicle's electronic systems without starting the engine. This action prepares the onboard diagnostic system to report the fuel tank pressure sensor voltage. Utilize the Honda Diagnostic System, HDS, to check the FTP sensor voltage displayed on the screen. If this voltage exceeds 3.62 volts, it indicates that the issue is confirmed, and further steps can then be initiated to narrow down the problem. Always ensure safety during this process by keeping the vehicle in a secure parking space. The second troubleshooting step necessitates starting the engine and maintaining a steady speed to identify any potential abnormalities. After starting the engine, elevate the engine speed to a consistent 3,000 revolutions per minute, RPM, while ensuring that the vehicle is in a no-load condition, meaning the continuously variable transmission, CVT, should be in park or neutral. This action encourages the PCM to assess the FTP sensor under specific engine conditions. Maintain this RPM until the radiator fan activates, which indicates that the engine is reaching operational temperatures. Following this, allow the engine to idle and reflect on the readings displayed on the HDS. As you monitor the onboard diagnostics OBD status for DTC P0450, you can ascertain whether the code remains active. This step is critical for identifying if the FTP sensor failure stands confirmed or if further investigation is necessary. The third troubleshooting step involves a critical inspection of the FTP sensor and its associated wiring. Begin by disconnecting the 3P connector for the FTP sensor, which houses the electrical input and output circuits for the sensor. This disconnection allows for a focused examination of the connections and surrounding wires. It is crucial to check for any visible signs of damage, such as frayed wires or corrosion. Using a multimeter, inspect the FTP sensor connection to confirm whether the wiring meets specified continuity parameters. If any open or shorted circuits are detected, this would lead to a malfunction. Once the inspection is complete, and if it appears normal, the next steps involving PCM evaluation can be explored for a complete diagnosis. The fourth troubleshooting step emphasizes evaluating the wiring associated with the FTP sensor and its connection to the powertrain control module, PCM. Prior to any disconnection, jump the SCS line with the HDS to secure a clean diagnostic environment. After waiting for over a minute, disconnect both the FTP sensor and PCM connectors to gain unhindered access to inspect the circuits. With these connectors disconnected, perform an open wire inspection on the P-tank signal, ensuring that the resistance reads less than 1 ohm. Next, conduct a similar examination for the SG6 ground line. Both of these checks are critical as they provide insight into whether the signaling is compromised due to faulty wiring. The absence of issues in these circuits leads to the conclusion that wiring is functioning correctly, allowing technicians to focus on diagnosing the PCM subsequently. In the fifth and final troubleshooting step, evaluate the PCM after confirming that all other inspection items have resulted in normal conditions. If the FTP sensor and wiring tests indicate no faults, this inevitably points to the PCM itself potentially being the source of the problem. Inspect the PCM for any signs of physical damage, corrosion, or faults in its electronic components. The PCM executes crucial roles in controlling engine operations and communicating diagnostic trouble codes. Thus, a malfunction in this module may hinder proper vehicle functions. If any abnormalities are noted, a replacement might be necessary. If the PCM shows no visible issues, but continues to display DTC P0450, further evaluation may be needed, possibly requiring specialist equipment or dealer involvement. Once the necessary repairs are completed, the final step is to verify that the issue is resolved effectively. Begin by clearing any DTC codes stored in the vehicle's onboard system. This action will reset the diagnostic network and enable you to monitor if the issue reemerges. After clearing the codes, Conduct a test drive under various operational conditions, including different speeds and loads, to assess the vehicle's performance. Observing behavior during this drive will give insight into whether the fuel tank pressure system has returned to normal function. Importantly, keep an eye on the check engine light and any OBD status codes while driving to ensure the DTC P0450 does not reappear. This wrap-up is essential for guaranteeing reliable vehicle performance and ensuring customer satisfaction. To mitigate future occurrences of DTC P0450, embracing a proactive maintenance strategy is essential. Regular inspections of the fuel tank pressure sensor will allow early detection of any issues, ensuring timely repair or replacement. It's crucial to maintain the integrity of the wiring and connectors leading to the FTP sensor and PCM, as corroded or damaged wires can introduce a host of electrical faults. Furthermore, whenever repairs or replacements are necessary, always use quality parts that meet or exceed the original manufacturer's specifications. This step prevents premature failures and promotes the durability of the components. Lastly, keeping a record of vehicle maintenance can aid in tracking patterns that may indicate systemic issues, ensuring that the vehicle continues to operate smoothly for years to come. In conclusion, DTC P0450 serves as a vital indicator of issues within the fuel tank pressure monitoring system, vital for optimal vehicle performance. Understanding the role of the FTP sensor and how it interacts with the PCM provides valuable insights into diagnosing and repairing issues with this system. Through effective troubleshooting steps, technicians can pinpoint faults, ensuring a systematic approach to repairs. The repair process not only addresses immediate concerns, but also sheds light on the importance of preventive maintenance to avoid future complications. Ensuring that all components are functioning within specifications and maintaining routine checks can greatly enhance the longevity and reliability of the vehicle. By combining understanding, diligence, and preventative measures, you can assure a well-performing Honda Civic for its owners. Please like and subscribe to the channel. See you next time.